is during 12th hour, they asked some pretty good questions as far as how these things work and why they work and why is it this way and what is it called and blah, blah, blah. And like I said yesterday, this whole way of showing you guys how this works is done via the pre-calc way. So it's, yes, it's a little over your head right now, but it's an honors class, so I'm just going to push you a little bit because that's what I do. Now, what I broke down I didn't say broke down, but I came up with an idea of writing it out that makes a little bit more sense to remember the basic rule. Yeah, go ahead, Cole, no worries, bud, no worries. I looked at it as this. Anytime you have a positive first term raised to an even exponent, your tails are up.
So it's that?
Yeah. Positive first term to an odd exponent. As I'm reading it, I'm going to say tail down, tail up, because we're looking at it going from left to right. Tail down, tail up. If it's negative to an even, tails down. And if it's negative to an odd, tail up, tail down. This works every single time for any polynomial whatsoever. What we're looking at here is the leading term of the polynomial. When we're looking at the leading term polynomial, it's always going to be the term part of the polynomial with the highest degree. Okay? I don't believe I gave you anything on that sheet that was not written in descending order, but from time to time you will see problems that they kind of throw at you and they don't put it in the descending order, which they force you just to kind of rewrite real quick. Okay? That is very, very common. Now, what I was hoping that you guys were able to do via that sheet from last night was to, if at anything, just go through the 10 or 12 that I had on there and point where the tails are going. And what I mean by the tails are, what are the ends of the graph doing? Because as you start to break into this further and further, if I look at it in terms of a regular graph, and my tails are pointing up, I know that it had to have been a polynomial with a positive first term with an even exponent. Now, the way that I would write this, what is happening as it's getting larger, this is where the write-outs tend to get a little interesting. As x is approaching positive infinity, as x is getting larger, what is f of x doing? It's also getting larger. So that means as x is getting larger, f of x, you're right, it is y, but we're talking these in terms of function notation, okay? We'll say that f of x is also getting larger. Does that make sense? And the x generates the y. I saw that one happen here like 30 seconds ago. The x generates the y. X is a function of function of x. Same idea. As x is getting smaller, as it's going this direction, what is f of x doing? Oh, it's also increasing. Remember, the tails. What are the tails doing? The tails are still pointing up, so it's doing this. Your book writes it backwards. The pre-calc book writes it backwards. I have absolutely no rationale for the reason of saying as f of x is getting larger, x is getting smaller. When yet, every single thing that you guys have ever been taught is always to go ordered pairs, x, y. See what I'm saying? So myself, I know Mr. Fontana, I don't know if Mr. Piscotta does it this way, but we always like to put the x value first because it just, in my head, it's the first value. Okay? So your book will describe it differently as to what we did. I showed you guys a method to talk about the tails via first term. Tails up, tails down, tail down up, tail up down. Just looking at the graph going from left to right via first term. This is easy to think about. As we start to write this out, and we'll do this more and more as we go through some of these examples here, as we start to talk about how you can write it in terms of f of x and x, with infinities thrown in there, we'll build into that. We're not quite yet ready for it, but just so you guys see where this is heading. Okay. Now, Abby, you had a question about something before I get into the worksheet there.
No, it's about the worksheet. So
Okay.
it's fine.
Now, on the worksheet itself, I know that for a fact there were the couple things that were thrown in here weren't quite ready for you to be factored because you haven't done some of the upper polynomial factoring yet. There are a couple in here that, if you recall, your first rule of factoring is to do what?
GCF.
GCF. If you took a GCF out, then you should have been okay. So let's do a couple of these and see how we're sitting.
Oh, yes, thank you. I think the second one we did in class is a third example yesterday.
I think you're right, yeah, so, all right, that's fine. So let's look at the first one then.
First forward.
First one, what are the tails doing?
They're going up.
They're up.
Up and up.
Tails are up. So I know for a fact that my tails are up. Now, I'm hoping that you guys were able to plot the zeros for that without a hassle.
No.
What are the zeros for that function?
Plus square root of 5.
Plus or minus root 5, right? Okay. So, if not for anything else, if you did this,
That's actually
Why
exactly
is this
what
pencil not working? I'm really good here.
isn't that what it looks like?
That's all it looks like.
I mean, I guess so.
Wait, how do you know
It's-
that it's not on like 1? It's not 1x where it was like the x is on root 5? How do we know that it's negative root 5?
It's the zeros. Whatever we were doing here, remember, to find the zeros, you set this equal to 0 and solve for x.
Okay.
So you get x squared equals 5, so x would have to equal plus or minus root 5. Those are your zeros.
Oh.
Now, what you're saying, though, is that you could also, you know what this point is. What's this here? Yeah, you're right, negative 5, but what's the value?
And negative 5.
Negative 5. Do I care if it's there or not? I'm looking at a rough sketch via tails and zeros. Okay. Tails and zeros. X and Y intercepts, all those are just, excuse me, not X intercepts. The Y intercepts is just bonus material. The Y intercept is just a bonus material. Right? We did 2 in class, so let's look at another one. So f of x is 49 minus x. That's not in descending order, is it? Nope. So I have to, that way I know that if I rewrote it, I get negative x squared plus 49. Which way am I pointing now?
Down.
Down. I know it's supposed to be tails down. I know it's going to be tails down, and I also know that 49 equals x squared, so what are my zeros? And?
7.
Oh.
Negative 7.
Negative
Negative
7.
7.
7 to negative 7.
Okay.
Okay. So I'm going to have plus or minus 7 for my zeros. Remember, all you're doing to find zeros is you set the function equal to 0 and solve for x. So you know tails down. Here's negative 7. Here's positive 7. And what would its y-intercept be?
49.
49. Do I care?
No.
Tails. Okay. Not so scary, is it? Nope. All right.
Wait till you get
We'll get there. Tails up, tails down on 4. Tails are up, first term's positive, exponent is even. So what times what's 25 you add together to get 10?
5.
And 5. So this is works out to be x plus 5, x plus 5. Now we talked a little bit about this in terms of what's called a multiplicity. Remember that from yesterday?
Kind of.
A multiplicity is actually more of a pre-calc term. It means that the 0 is repeated. Pete and repeat were in a boat, Pete fell out, who was left?
Repeat.
Pete and repeat were in a boat, Pete fell out, who was left?
Repeat.
Pete and repeat were in a boat, Pete fell out, who was left?
Oh,
Pete and repeat were in a boat, Pete fell out, who was left?
Pete.
The one who's not Pete, there it is. So this has what's called a multiplicity at negative 5. It means it's repeated more than once. Okay. Did you have to get it explained?
Yeah, he did.
No,
He did. He got it.
I got it.
I got it. I got it after like the first one.
Now remember, when we talked yesterday about possible zeros, it being a squared function means it can have up to 2 possible zeros, 1 0, or it can have 2 imaginary solutions. In this case, we have 1 real solution, which means it just touches the x-axis at -5, and the tails are up. So far, so good? Okay. What do you do in 5?
Oh, I don't know.
What's the GCF?
1/3.
1/3. Then it's easy. First rule of factoring is GCF. So what's going to be 2/3 divided by 1/3?
2.
2. Oh, sorry, that's a plus. So you wind up, now when I set that equal to 0, does the 1/3 have any bearing left?
No.
No. But if I look at my original problem, will it be tails up, tails down?
Tails up.
Tails up. So we know it's going to be tails up. What times what's -2? You have to be able to get +1.
-1 and 2.
-1 and 2, very good. Zeros then are at 1 and -2. Tails up. Yes, sir.
I think you said about the exponent.
Yeah.
How we can only have like minus, like 2 minus 1, so we only have 1 0. Right?
That was turning points. I could have up to that many changes of direction.
So that doesn't apply to that.
It does apply to this because it changes direction in one place. See how it's decreasing, then it increases. That's what that
I
means.
thought it meant how many zeros it can have.
No, the zeros is the possible of the degree,
Oh, okay.
and then it has n minus 1 possible turning points.
But
Okay. What's the first rule of factoring, ladies and gentlemen?
Take out the GCF.
What's the GCF in this one?
X.
X. So, factor out an x, and you're left with. Oh, before I do that, I got ahead of myself. What are the tails doing?
Going up and one's down.
Which one's which?
Left is down.
Left.
Is right.
That was pretty funny. We should all dance.
No.
Stand up and dance.
Mike is so ready.
I'll dance.
I'll do it.
Ready?
There's no music. Wait, which one?
Good music.
Ready?
What are we doing?
Show me positive even. Positive odd. Negative odd. Negative even. Positive even. Negative even. Positive even. Positive odd. This is great.
Pretty good.
Oh, never a dull moment. So, what were the tails doing on this one again?
Left is down, right is up.
Correct. So we call it the stay in alive move. Stay in alive.
No, that's for
Oh yeah, that's right. What times what's 4? You had to get -4.
I can do
So what do we call it? A multiplicity at 2. So you went with x minus 2, x minus 2. So now you have 3 terms set equal to 0, which means you can have up to 3 possible zeros. Yes, ma'am.
Okay,
Honestly, why do we keep the x?
divide out by like a coefficient, which is like get rid of it.
Because it's an x. Before we were looking at, there were just constants. If I divide by x, I'm eliminating a possible 0.
Yeah.
And this is what
I think
happens.
that's it.
I cannot divide, when I set this equal to 0, if I divide both sides by x, I am eliminating a possible 0. When we had coefficients, just like we factored out a 3, or the other one before, we factored out the 1/3. When I factor out the 1/3, I can divide by the 1/3 and it doesn't change anything. I don't lose any possible zeros. But the moment I take out a GCF that has a variable to it, it has to come along for the ride. And that's one of the rules that we'll start to develop and learn more about with polynomials, with factoring. So you have 3 terms to set equal to 0. Well, x equals 0, that was easy. x minus 2 is 0, and x minus 2 is 0. This means we have a multiplicity at 2, because 2 is repeated for a 0. And the other 0 is at 0. So the graph of this, knowing that you are increasing, going from your tail is down, and the tail is up, I'm going to cross the axis at 0 and at 2, which means I'm going to have to change direction in here. It's going to increase, decrease, and increase again. But I can only touch the axis once at 2 because of that multiplicity.
But crossing through 0 doesn't.
Okay. Whereas if this was a little bit different, if it was at 0, 2, and 4 for your zeros, I'd be at, well, 0, 2, and 4, where I'd be increasing, change the direction, change the direction. I'm still changing my direction n minus 1 possible times, twice, but it just so happened that I'm only crossing the x-axis twice, not 3 times. That's where the whole idea of the multiplicity comes into play, the repeated 0, as well as sometimes we'll get the imaginary solution where the curve will not touch it, it'll touch it above. Okay? Does that make sense? It gets a little, once you get a little used to seeing it a little bit more, it gets a lot easier. It really does. Okay? Excuse me. Sorry. Man, I'm just starting to feel like junk. Oops, sorry. Left that too loud.
Squared, I mean.
So this was x to the 4th minus x cubed minus 20. X squared.
Oh, this makes more sense. What's the number?
So, first rule of factoring. What's my GCF?
X squared.
X squared. So if I factor out the x squared, I'm left with, well,
X squared minus x minus 1.
now this tells me something on the outside here, that I'm going to have a multiplicity where? At 0, because it's x squared, because I'll have to set this value equal to 0, which means 0 will be hit twice, because it's an x squared.
Wait, why is it?
Here, I get minus 5 plus 4.
Yeah.
So we have zeros at 0, 5, and negative 4. Now,
This was just like an automatic 0 whenever it's a x something
yes,
anything.
because what you're doing here is you're setting this equal to 0. Okay. Since it's a 4th degree polynomial, that means I can have up to 4 zeros. Since I factored out the x squared part, that means that this 0 is repeated, because you can do this. Isn't x squared x times x?
Yeah.
And then I can go x minus 5, x plus 4. That's why that works. So in a graph, when we're rough sketching this, it is a first term positive, and it is a even exponent. Where are my tails? Both tails are up. It's going to be at 0. 1, 2, 3, 4, 5. And 1, 2, 3, 4. So it's going here, change the direction. Probably looks something like that. Is that what it looked like in the graph? Did you guys graph it?
Yeah.
No, even on the graph, even in your equation, because if you start, it should. Let's see, do I have a graph?
We don't have to do that right now. That's not gonna work. I'm really irritated when I'm gonna tell her.
It was, what was it, x to the fourth?
X to the fourth minus x to the third minus x 20, 20x.
What was it, x to the fourth minus x to the third minus,
20x.
And then like, I'm decent from that, because that's what we have, like, more problems is, so it's like, then you can just have this.
hey, 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 look at that.
It's not gonna work.
Mario.
Because,
I mean, I took this twice.
I don't even know what that means. Now, you guys have probably never factored a polynomial like this.
No,
I didn't expect you to.
So let's go back and think about this for a second. No matter what is the first rule of factoring?
GCF.
So I'm going to find my GCF, which means I'm going to factor out an x, and I get x times x to the fourth minus 6x squared plus 9. Now, what I want you to do here is think about the rules of exponents. Fourth, then a squared. What's x squared times x squared? X to the fourth. So couldn't I factor this with x squared up front? Yeah.
Why not? Just might as well.
Might as well, exactly. So what's 9 you add together to get negative 6? Forgot to bring my x down. So I set all of these equal to 0, and I'm going to get x is 0. For this one, x is going to equal plus or minus root 3. And for this one, x will wind up equaling plus or minus root 3. Which means I have 5 possible zeros, but I really only have 3 of them because 2 of them have multiplicity. 2 of them are repeated. It's kind of fun. There was a movie called Multiplicity.
What?
Michael Keaton. It was awful.
Michael Keaton's pretty cool though.
Sounds awful.
Yeah, he was like 5 or 6 of himself. He cloned himself to do more stuff around the house. And then one of the clones fell in love with his wife, and he didn't know who was who. Spoiler alert.
Spoiler alert, someone died.
It's like Homer Simpson. He was the clone in one of his episodes, and they figured out which one it was because he didn't have a belly button.
wait,
Tails. What are the tails doing in this one? Down, up. Very good.
It's a Halloween movie. Halloween Town 2? Halloween University?
Thanks for trying.
That's right.
So it's increasing. Now remember, I've got the multiplicity at negative 3, so it means it's going to come up, touch it, come down, go up, touch it, and go.
what the freak?
That's cool.
Remember, if you've got multiplicity, that means it just touches it at that axis and changes direction right there.
Okay.
Okay? Just like when we had x squared minus 4, it was, well, no, that's not it. Just when we had, what was it, x minus 2, it touched the x-axis at 2 and just changed direction. Well, here it just does it twice. That's all. And that's what that would look like. Yes, ma'am.
Why can't it be like that?
Because what you have right there is it going through the axis, when yet it has to touch it twice. Since this is a repeated 0, you have, let me rewrite this here. We have zeros at x equals 0, x equals negative root 3, x equals negative root 3, x equals root 3, and x equals root 3. By rewriting it out, you'll see that there are 5 total zeros. 2 of them are repeated. Whenever you see a repeated 0, that means it's touching it at that spot and changing direction. Okay? No matter what. Now, that's the whole idea by doing the tails. Knowing that my tails are going left, starting down, left, up, right, I know that I'm, so we've got root here. I know that I have to come up, touch, change, go through, change. Okay? That's the idea by identifying if there is that multiplicity. This kind of fun to say. Why are you throwing pencils at me? I was nice to you. I do that every day. Yes, ma'am.
I'm confused as how, where did you get the x squared from?
The trick that happens here is that when you see fourth degree, second degree,
It's only if it's fourth and second.
it actually works with sixth, third. I mean,
Oh, so like if it's half.
yeah.
Okay.
Whenever the next term is half of the exponent, because when you multiply them together, you're adding, and that's how it's supposed to be. So it was 84. You'd be like, geez.
So if it was 8 and 4, it'd just be x.
X to the fourth. and
Oh,
then-
it'd be the
Yeah.
half term, okay.
It happens all the time. Okay, it's a very, very common situation. Now, the last couple that we probably didn't spend much time on was the style in which you have to factor via grouping. Factor via grouping usually
Those are the
occurs.
fun ones.
Those are the ones we did.
You did a little bit of this. This is more common when you have an odd exponent with 4 terms. You'll see this a lot with odd exponents with 4 terms because it's going to force you to group them in GCF 2 pairs. Odd exponent, first term is positive, means down, up. So what I do here is I throw parentheses and I take 2 sets of GCFs. What's the GCF of x cubed and 3x squared?
X squared.
Factor out an x squared, and I have x plus 3. Here I'm going to take out the negative 4, and I have x plus 3. We used this grouping method when we had first term coefficients that weren't 1 with our quadratics. Remember that, how we'd split the middle term? It's the same basic principle, but they're starting with 4 terms right away.
Wrong. I don't know if I just.
Are these the same?
Yes.
Write it down. And then you have x squared minus 4, which means my zeros are going to be at negative 3 and plus minus 2.
It's
that?
like 2 and then a negative
Yeah, because you add 4 and take the square root, so that's where you get the plus minus. Bless you. I think I did the next one in class yesterday, didn't I?
I don't know, but I didn't.
Yeah.
Yeah, you did.
Yeah, you did.
Wait, how do you graph?
How do I graph that? I put my zeros in. Increasing, going from left to right, so it comes up, down, and up.
I thought you couldn't go down with
It's great.
It's great.
oh, never.
Oh.
Now it's not touching the other one. He tried.
I tried. So we have negative 3, negative 2, so it's going up, changes, down, and comes back up. Eventually, we're going to start figuring out where what's called a localized maximum, localized minimum, relative maximum, or relative minimum. But use calculator. Yes, sir. Yes. Where did I get the negative 3 from? I set all these equal to 0. I just found the zeros.
I thought it had multiplicity. That you couldn't-
It doesn't have multiplicity though, because this is x squared minus 4, so it's x plus 2, x minus 2.
Aren't there 2 x plus 3?
Nope. Oh, you're thinking this is the GCF. Are these two? Remember we factored by grouping. Are those 2 pieces the same? So I factored it out, and I'm left with x plus 3, x minus 4.
Oh, okay.
Okay, that's what that works out as. So there wasn't multiplicity there. Yes, ma'am. That was that whole trick by factoring by grouping. All right.
I took the wheel home the bus. I got without that. Without that. You want to go check the school to see if there's someone in there.
11. First term is positive, exponent is odd, so we are down up. GCF is x.
I did it 4x.
No, because you could. Can't factor the 25 out.
But when you go to factor this one should be relatively simple. What times what is 100? We add together to get negative 20.
10.
Negative 10, negative 10. So you factor this out, you get 4x squared minus 10x
Dang it, that's
minus
more
10x plus 25.
Wait, why is it so long?
Because I have to split the middle term, so I
Oh,
gotta
okay, I
do the
gotcha.
grouping.
So you just gotta-
Yep. As leading term coefficient is not 1.
Okay.
Now we take our GCFs. Now we take out a 2x, and I have 2x minus 5. Take out a negative 5, and I have, dun dun dun, 2x minus 5. These two are the same. So we have x, 2x minus 5, and 2x minus 5. So I have three possible zeros, one of which has multiplicity. I have multiplicity where?
2x minus 5.
5 halves, very good. I have multiplicity of 5 halves. So my zeros will be at x equals 0 and x equals 5 halves. Okay. Remember, we set all of this equal to 0. Since this 5 halves is duplicated, that means it's just touching the axis at 5 halves and changing direction. It does not pass through.
Do you want to we graph it to the straw lines, or can we just kind of like sketch it without lines?
I would sketch it with the lines so you place in your zeros. And the zeros haven't been all that crazy.
Crazy for me.
I'm just waiting for the hard part.
So you did everything like all
It
the
gets
math
there.
work,
It
but
gets
it's
there.
just like-
I knew we weren't going to get into the synthetic stuff.
What's
We'll
X
do that
squared? I got
tomorrow.
confused when I asked you.
I just don't think I can do it.
You said not.
Yeah, what I want you guys to do tonight is we're going to take the factoring back to bless you.
Oh, it's not. Is it either 12 or is it
No, I don't think so.
On 12 works? Same as
12.
Because you pull out 1x, and then you get x to the 4th minus 5x squared plus 4x.
Can you do 5? Sorry. 12.
I just did.
12?
Did I do 12?
That was 11.
Oh, yeah, here, let me finish out with 12 before I do this. Sorry.
No, you're fine.
I thought I had just done it.
I didn't understand this one.
What's first rule of factoring? Ladies and gentlemen, come on. First rule of factoring. What is it?
X.
Okay. It's going to be x. What are your tails doing on this one?
Up and down. Down and up.
Down, up.
Bam!
What times what's 4 you add together to get negative 5? So we have x squared minus 4. X squared minus 1. Which gives me zeros at 0, plus minus 2, and plus minus 1. I have no repetitive zeros. I have all 5 zeros, which means I'm going to have how many changes of direction? 4 of them. Remember, it's one less.
That's it.
So tails up, so it goes.
I signed 4.
Oh, no.
Wait.
What's that?
A lot easier when you have 3 screen.
It's not bad, right? Sound effects is where it's at. Hey, just so you guys know, this graph right here, if I look at just this portion of it, starting at 0, going up, going back down, and going back up, boy, that looks a whole lot of like a sine graph. Just wait till we get to trig. Woohoo! It's trigging out, trig, kids.
I'm not doing that.
I won't vote.
So what I want you to do tonight. Great math problem.
Whatever happens, I'll do it.
Can I be exempt?
So,
I didn't even take
$60 is on the line.
I went $60.
You said. Dude, my kid like, oh, he sucks at trivia. I'll bet him $60 that I'll beat.
All I want you to do, is not all these things are nicely factable to find zeros and stuff like that. I want you guys just to go through those dozen problems and tell me what the tails are doing.
That's it.
And what I mean by that,
What about graph? That's it?
that's it.
Just say what they're doing.
Just tell me tails, guys.
That means the
So
hard
I
part
just
is
say up and down or down.
Just tell me tails.
that means the hard part is really hard to know.
So basically on 53, I would say, oh, I'm looking at 53. If it's positive and odd, I do this.
That's it?
Yeah, just do that.
Is that the answer?
I don't know. I haven't done it. Oh, it might be. I have a 1 in 4 chance of being right, but I have a 3 in 4 chance of being wrong.
I hate when that's right. Is that right?
It's negative and even. I couldn't be more wrong than positive and odd. Okay?
You got me there.
Are we gonna have a quiz come up soon?
Eventually. I don't know when. No problem. We have tomorrow. Tomorrow we'll talk about the other part that's in this section called synthetic substitution. Synthetic substitution is going to be a method for us to do factoring ridiculously quick. Okay. Synthetic substitution allows you to factor upper level or upper degree polynomials in like no time whatsoever. It is an awesome, awesome, awesome little thing. It is awesome.